Okay, let's see an example of how we use hydrides. So, here is an alcohol. Let's say we want to make this alcohol. Well, when we only knew about organometallic reagents, we might have said, fine, you want to make that alcohol? That alcohol came from a carbonyl compound. And so I'm going to start my carbonyl compound with hydrogens flanked on either side of the carbonyl. And then to make this alcohol, we're going to add in the phenyl group, the benzene ring. So we would react this with some kind of phenyl organometallic, maybe phenyl magnesium bromide. Second step would be water. This will attack. We'll form a tetrahedral intermediate. Then once we dump in the water in our second step, we'll protonate that tetrahedral intermediate, and we'll get that alcohol. Now that we know about hydride reagents, we can instead say, let's begin maybe our carbonyl that made the alcohol started with a benzene ring and a hydrogen on it. So there's our carbonyl. On one side we put the benzene ring, on the other side we put the hydrogen. And now we could treat this instead where we want to add the hydrogen. Well, we're going to add that as hydride. Again, just like up top, we had an organometallic as our strong nucleophile. Now down here we have hydride as our nucleophile. And hydride could attack our carbonyl. That'll form a tetrahedral intermediate with the O-. And then step 2, since we're using lithium aluminum hydride, we can't have water in there. We'll add the water. And we will get the same alcohol. So hydrides are great nucleophiles for carbonyls, and we can use them just like we'd use an organometallic reagent. Of course, we're not adding any carbons, we're just adding a hydrogen. But both of those are very useful and helpful reactions when we're talking about chemistry and doing attacks on carbonyl compounds.